Today we are going to be talking about section 6.1 and we're going to be talking about polygons. The first thing I'm going to have you do is create a shape that consists of more than 3 lines. So if you have a ruler at home, I want you to go grab one. If not, just try to make the straightest possible lines that you can. I'm going to draw a shape as well. Once you've drawn your shape, I want you to answer these 3 questions. Is your figure open or closed? So let's see, my figure is open. Does your figure have any curves? Well, all my lines are straight, so no, it doesn't have any curves. No. And how many sides does your figure have? So everyone's going to have a different number of sides, but 1, 2, 3, 4, 5. Mine has 5 sides. So we have a definition, a polygon. So a polygon is a plane figure that is formed by 3 or more segments. So just what we drew before, that's a polygon. Had 3 or more segments. Also with a polygon, it has to have straight lines and it can't have any curved sides. So in a polygon, our sides are the lines that make up our polygon, and our vertices, they're the points that connect 2 sides. Those are vertices. If you want to pause the video and go back to your polygon that you drew on the previous slide, label your vertices there. What are your vertices? What are your sides? What does consecutive mean? We're talking about consecutive vertices. So 2 vertices that are the endpoints of the same side are called consecutive vertices. So let's see, if we're looking at this side right here, side ST, well, my endpoints of ST are that vertex S and vertex T. So that means we call vertex S and vertex T, those are consecutive vertices. They are next to each other. Another example is if we look at our side right here, RS. Well, vertex R and vertex S are consecutive vertices because they're on either sides of that side RS. Take a moment. I want you to think of another pair of consecutive vertices. For example, you could have said PQ, VU, UT. There are many different options of consecutive vertices on this figure. Next, we're going to talk about diagonals. So diagonals are the segments that join 2 non-consecutive vertices. So if we look right here at vertex R, there's 4 different diagonals coming out of vertex R. So for example, RP, RV, RU, and RT, those are our diagonals. Now if you notice RQ, we can't draw a diagonal from R to Q because those are consecutive vertices, same with RS. But R and P aren't consecutive, so we can draw a diagonal. You can also say start at vertex S and draw, say, a diagonal. We wouldn't draw 1, 2, vertex R because they're consecutive, but S and Q aren't consecutive, so I can draw a diagonal to them. And same with SP, SV, and SR, but not ST because those are consecutive. If you want to go back to that first shape you drew and draw the diagonals, and you can pause the video to do this. Okay. Are these figures polygons? Explain your reasoning. Well, if we look at figure A, let's see, we notice that it has 4 lines, and we said that before polygons have to have at least 3 lines, so it has 3 plus lines. That's awesome. Let's see, they're all straight. That is one of our criteria points. And let's see, it is a closed figure. So we'd say yes, figure A is a polygon. Now if we look at figure B, let's see, Does it have 3 plus lines? Well, yep, there's 4 of them. Are they straight? Let's see, well, if we look at this line right here, it's not straight, it's curved. So we'd say no, because they're curved lines. That is not a polygon. I want you to pause the video and try polygon C and polygon D on your own. Okay, let's talk about polygon C. So let's see, if we look at it, there are 3 plus lines. Our lines are straight. But if we look right here, it is not closed. Or it's not closed, so we say no, it's not a polygon because it's open. If we look at polygon D, we notice that yes, there are more than 3 lines. All of our lines are straight. And it is a closed figure. So yes, it is a polygon. Okay, next we're going to talk about classifying polygons. So we can classify polygons by the number of sides they have. And we have special names for these types of polygons. I believe you should know these already, but just in case, we're going to have you fill out this table in your notes. So a triangle, that's a 3-sided polygon. A quadrilateral is a 4-sided polygon. A pentagon is a 5-sided polygon. A hexagon is a 6-sided polygon. A heptagon is a 7-sided polygon. And an octagon is an 8-sided polygon. If you don't know these already, I want you to work to memorize them because you'll need to know them later on. These are the only types of polygons you need to know. So you don't need to remember names for polygons not on this list right now. The awesome thing about polygons is they're everywhere. You can see them in your daily life. For example, road signs. So when you're driving, there's a ton of polygons. So each traffic sign is a polygon because it's made up of straight lines. They're all closed and they're all 3 or more sides. So if we look at this yield sign, it's a polygon. What kind of polygon is it? Well, it has 3 sides, so that's a triangle. What about the slippery road sign? Well, 4 sides, that's a quadrilateral. I believe many of you probably have these memorized from previous years, but if not, you can reference the table on these problems. Our crosswalk sign, well, that has 5 sides, so that's a pentagon. And finally, our stop sign, well, if you count the sides, there are 8, so that's going to be an octagon. Okay, let's see, we're going to decide if these are polygons, and if they are, we're going to say what type. So let's look at our first one. Let's see, it has more than 3 lines. Our lines are straight, and it is closed. So let's see, it is yes, it is a polygon. Now what type of polygon? Well, let's see, it has 4 lines, so that means it's going to be a quadrilateral. B, let's look at it. It has, let's see, more than 3 lines. Let's see, are they straight? Well, let's look at these lines right here. They're curved, so we would say no, it's not a polygon because there are curved lines. Now, because it's not a polygon, that means we can't classify it. Even though it has 4 lines, it's not a quadrilateral because it is not a polygon. All quadrilaterals are polygons. I want you to try these next 2 on your own. We'll go over them in a moment. Pause the video. Okay, let's go over these ones. Number C, let's see. Does it have straight lines? Yes, it does. Does it have more than 3 lines? Yes. And is it closed? Yes. So let's see. Yes, it is a polygon. Well, what type? If we count, there's 1, 2, 3, 4, 5 lines, so it is going to be a pentagon. Our next one, this one's new. So if we look at polygon D, we'll notice that there are straight lines. There's more than 3. There's 4 lines. Let's see. 1, 2, 3, 4. But because they cross, it is not a polygon. So for this one, we would say no because of crossed lines. If lines crossed, it is not a polygon. Okay, the next thing we're going to talk about is angle measures and angle sums in a quadrilateral. So the first thing I'm going to have you do is I want you to just draw a quadrilateral, a 4-sided shape on your notebook paper. So here's the one that I drew. Now I want you to try dividing that quadrilateral into 2 triangles. Let's see, I divided mine into 2 triangles that way. It's not the most accurate division, but here you go. I'll try to make that line a little bit better. Okay, so that quadrilateral worked. I want you to retest this. See if you can divide another quadrilateral into 2 triangles. So draw another quadrilateral. And I want you to see, can you draw this new quadrilateral can you divide into 2 triangles? Let's see, yep, I could. So this is telling us we have, let's see, 3 examples up on the screen, and you should have 2 examples in your notebook, that any quadrilateral you take, you can divide it into 2 triangles. So we're going to use this information to help us figure out what the angle sum is in a quadrilateral. Well, let's see. We know that the angle sum of a triangle is 180 degrees. And we can make any quadrilateral, we can divide it up into 2 triangles. Each triangle has a sum of 180 degrees. So this is 180 degrees. This is 180 degrees. So total, a quadrilateral will have have 360 degrees for angle sum, because 180 plus 180 is 360. So now is a great time to pause the video and take out your theorem packet if you don't have it out already, because we have a new theorem. So the quadrilateral interior angles theorem, theorem 6.1, is the sum of the measures of the interior angles of a quadrilateral is 360 degrees. Next, we're going to practice applying this theorem. So let's see. I have quadrilateral A right there. I need to find the measure of angle A. So we know what angle B and angle C and angle D are, but we need to find angle A. So first of all, the sum of my first 3 angles would be 110 plus 60 plus 110. Let's see. Oh, whoops. I messed up when I was writing it down. Go back. There we go. 110 plus 60 plus 100 is 270. So the sum of my first 3 angles is 270. I need to find my 4th angle. I know that all 4 angles together have to be 360 degrees. So I'm going to do 360, my total angle sum, minus 270, the sum of my first 3 angles. That's going to give me my 4th angle, the measure of my 4th angle. So 360 minus 270 is 90, meaning the measure of angle A is 90 degrees. Okay, we're going to try another one. Same process, I need to find the measure of angle A. Well, let's find the sum of my first 3 angles. So 55, whoops, that's a 5 right there, plus 80 plus 160 gives us 5. Let's see, 5 plus 8 plus 6 is 19. Carry the 1. 295 is my angle sum for my first 3. So my total angle sum, 360, minus the sum of the first 3 should give us the measurement of that last angle, my 4th angle. Let's see. Oh, I wrote this down wrong. Give me minus, 295. So 360 minus 295 is going to be 65. So angle A is equal to 65 degrees. Okay, I'm going to give you problem C. I want you all to pause the video right now. Try problem C on your own. Okay, now let's go over problem C. So the sum of my first 3 angles would be 72 plus 108 plus 108. Well, let's see. This is 18, carry the 1, 8, 288. So 360 minus 288 is 72. So angle A is equal to 72 degrees. Awesome, and that was our lesson on polygons. Thank you for watching. You can now try the homework.